Hey class, working with inequalities again today, multiplying and dividing and learning about the rules when multiplying and dividing. So we have to review our multiplying integers or dividing integer rules. So when you're multiplying or dividing with integers, if you multiply and the signs are the same, so you multiply a positive times a positive, your answer will be positive. Or if you multiply a negative by a negative, then your answer is positive. But if you multiply and the signs are different, then your answer will be negative. So positive times a negative is a negative, and negative times a positive is a negative. So let's just review that. So 6 times 5 is 30, but 6 times negative 5, since the signs are different, your answer is negative, negative 30. In number 2, the signs are the same. 6 times 5 is 30, and negative 6 times negative 5 is also positive 30. So same signs, positive answer. Sometimes we learn that as the pass rule is what it's called. So same, it says pass stands for positive answer when they have the same sign, okay? So 3 times 4 has the same signs, both positive, positive 12. 10 times negative 2, different signs, it'll be a negative answer. 10 times 2 is 20, so 10 times negative 2 is negative 20. Negative 2 times negative 2, same sign, positive answer. So 2 times 2 is 4, so negative 2 times negative 2 is also 4. The same thing works with division. 6 divided by 3 will be positive 2. Both positive, positive answers. But 6 divided by negative 3, different signs, negative answer. 6 divided by negative 3 will be negative 2. Negative divided by negative will be positive answers. So negative 6 divided by negative 3 is positive 2. Negative divided by negative is positive. So 4 divided by 2 is 2. 9 divided by 3, positive divided by positive, same positive answer when the signs are the same. So 9 divided by 3 is positive 3. So remembering your integer rules will help you out in this section today. So we're going to look at this statement. Consider this negative 3 is less than 1. Is this true? So if you think about that on the number line, 1 is right here, and I'd go 1, 2, 3, and then 0, then negative 1, negative 2, negative 3, negative 4. So negative 3 is right here, and 1 is right here. So negative 3 is less than positive 1. So that is true. So now let's consider the statement, negative 3 minus x. Is that less than 1 minus x? So basically, I'm wondering if I subtract the same number from both sides of my inequality, would I get an answer that is still true? So let's try it. So I have negative 3 is less than 1. Is negative 3 minus 5 less than 1 minus 5? So I had a 5 for my x. So I plugged that into the minus x spot. So I subtracted 5 from both sides. Now, negative 3 minus 5, they're at negative 3, and you're going to go back 5. So you're going to end back at negative 8. And then if you're at positive 1 and you subtract 5, you're going to be at negative 4. And is this true? Is negative 8 less than negative 4? And that is true because negative 4 is closer to 0. Negative 8 is less than negative 4. So subtracting 5 from both sides did not change my inequality. It stayed true. So is negative 3 minus negative 4 less than 1 minus negative 4? So if I subtract a negative number, does it still stay true? So negative 3, when I subtract a negative like this, it actually makes that a plus. When you have 2 minuses in a row, that means I'm actually adding. So a negative and a negative is a positive here. So this is negative 3 plus 4. That's 3 negatives plus 4 positives. It would equal positive 1. And then on this side, I end up 1 minus negative 4 is the same thing as 1 plus 4, so that's 5. Does my inequality stay the same? Is 1 less than 5? Is that true? and it is true. So if I subtract a positive number from both sides, it stays true. If I subtract a negative number from both sides, it stays true. What if you subtracted 0 from both sides? Like if I knew that negative 3 was less than 1, is negative 3 minus 0 still less than 1 minus 0? And yes, because minus 0 does not change the problem. So what conclusion can we come to here? You can subtract any number from both sides and the inequality stays true. Or basically, as long as you subtract the same number from both sides, you get a true inequality. Let's try it with multiplication this time. So 5 is less than 7. Is this true? Yes. You can see on your number line, you have 3, 4, 5, 6, 7, 8. 5 is clearly less than 7. 5 is to the left of 7. Now, I want you to consider the statement 5 times x. Is that always less than 7 times x? And we'll try that. So I know that 5 is less than 7. So now I'm going to try where x is 2. So is 5 times 2 less than 7 times 2? Well, 5 times 2 is 10, and 7 times 2 is 14, and 10 is less than 14. So multiplying by 2 did not change my inequality sign. It's still less than. Let's try it with 10. 5 is less than 7, so is 5 times 10 less than 7 times 10? Well, 5 times 10 is 50, and 7 times 10 is 70, so 50 is less than 70. So multiplying by 10, my inequality stayed the same. It's true. Okay, let's try with negative 3. 5 is less than 7. Is 5 times negative 3 less than 7 times negative 3? Well, when you multiply 5 times negative 3, you have a positive times a negative, so you get a negative answer, negative 15. And then 7 times negative 3 would be negative, and 7 times 3 is 21. So is negative 15 less than negative 21? That is false. Negative 15 is actually greater than negative 21, because if you think about it on a number line, 0 is right here, and then it goes like negative 5, negative 10, negative 15, negative 20. Negative numbers get bigger as you go further to the left. So negative 15 is actually closer to 0 than negative 21 is. So negative 15 is actually greater than negative 21. So we had to flip the inequality sign there for it to still be true. So let's try one more here. If I know that 5 is less than 7, what if I multiply both sides by negative 1? Well, it's 5 times negative 1, and is that less than 7 times negative 1? Multiplying by 1, you get the same answer. Like 5 times 1 is 5. But 5 times negative 1 is negative 5. Positive times a negative is negative. 7 times negative 1 is negative 7. Positive times a negative. Is negative 5 less than negative 7? It is not. Again, looking at the number line, negative 5 is closer to 0. Negative 7 would be like right here. It'd be like negative 5 degrees is warmer than negative 7 degrees. So you have to flip the inequality to make this true. So when I multiplied by a positive number, the inequality didn't change. But when I multiplied by a negative number, I had to flip the inequality around to make it a true statement. So this rule does not work for all cases, the multiplying. We learned from this example that when we multiply by a negative, it changes the inequality statement. So when you multiply by a negative, you have to flip the inequality. Let's try it with division and see what happens. Is this statement 4 less than 8 true? Yes. Now, if you think about it on the number line, you got 0, 2, 4, 6, 8, 10. 8 is further to the right of 4, so 8 is in fact bigger than 4. Now consider dividing both sides by the same number and see if it stays the same. So we know 4 is less than 8. Is 4 divided by, if x is 2, is 4 divided by 2 less than 8 divided by 2? Well, 4 divided by 2 is 2. 8 divided by 2 is 4. 2 is less than 4. So that one works. What if x is equal to 4? 4 is less than 8. What is 4 divided by 4? And is that less than 8 divided by 4? 4 divided by 4 is 1. 8 divided by 4 is 2. 1 is less than 2. So far, I have divided by two positive numbers. My inequality has not changed signs. Let's try it with the negatives. 4 is less than 8. That is a true statement. Is 4 divided by negative 2 less than 8 divided by negative 2? Well, 4 divided by negative 2, just like 4 divided by 2 is 2, 4 divided by negative 2 is negative 2 because it's a positive divided by a negative. And then 8 divided by negative 2 would be negative 4. And is negative 2 less than negative 4? That's incorrect. Negative 2 is actually bigger than negative 4. Because if you were to continue this number line here that I drew, this would be like negative 2, negative 4, negative 6, counting by 2's. Negative 2 is closer to 0. Negative 2 is actually bigger than negative 4. Just like negative 2 degrees would be warmer than negative 4 degrees. So it's greater than. I think you might be catching on here, but do one more. 4 is less than 8. So is 4 divided by negative 1 less than 8 divided by negative 1? Well, 4 divided by negative 1 is negative 4. 8 divided by negative 1 is negative 8. And negative 4 is actually greater than negative 8. So when you multiply and or divide, when the numbers were negative, you had to flip the inequality sign. So that is what I want you to get from this. All right? So wrapping it up. If you divide each side or multiply by a negative number, the resulting statement is not true. So then you have to flip the inequality sign around to make it true. Greater numbers are always to the right on the number line. So just remember that when you're looking at negative numbers, the further to the right they are, the bigger they are. So negative 4 is greater than negative 8. Negative 4 is greater than negative 8 because it is closer to 0. It's more to the right. So one more time, if you multiply or divide by a negative, you must reverse the sign. Remember, for adding or subtracting, we did not have to reverse the sign, but if we multiply by or divide by a negative, we do. So let's apply what we've learned now to solving with inequalities. So we have 3x greater than 12. Remember, 3x means 3 times x greater than 12. And we learned to solve these one-step inequalities using our inverse operations. So if I have 3 times x, the inverse of multiplying by 3 is to divide by 3. Now I want to do this to both sides here. I typically write it as a division sign like this. You know, you technically could write, I'm going to divide by 3 on this side, and then I'm going to divide by 3 on this side. When we divide, though, so that's the rule that we did, we're dividing by positive 3. So when we divide, we typically written it out as a fraction, though, because then we can see that 3 divided by 3 cancels. It equals 1. So we're left with x. And then since we only divided by positive 3, we're going to keep our inequality facing the same way. And 12 divided by 3 is 4. So this should be our answers. All our x's greater than 4 are our solutions. So 0, 1, 2, 3, 4. I wanted 4 in the middle. 5, 6, 7. It is an open circle at 4, and the x's that are greater than 4 are to the right. Okay, 1/2 w less than or equal to negative 5. So again, this means 1/2 times w less than or equal to negative 5. So the inverse operation, or to get rid of the times a half, would be to divide by a half. But when we divide by a fraction, we actually keep change flip. We multiply it by the fraction flipped over. So when you have a fraction like this, we need to multiply both sides by the reciprocal instead, because then the fraction cancels. 2 over 1 times 1 over 2 equals 1. We get 2 over 2. So we just get W left on this side, less than or equal to. We multiply over here. Negative 5 times 2 over 1 is the same thing as negative 5 over 1 times 2 over 1. Multiply fractions across the top. Negative 5 times 2 is negative 10. And 1 times 1 is 1. Negative 10 divided by 1 is negative 10. We did not multiply by a negative. We can keep our sign the same. Our answer is W is less than or equal to negative 10. So I put negative 10 on my number line. I count by 5s, negative 5 to the right, 0, 5, etc. To the left, it's going to get more negative. So negative 15, negative 20, negative 25. We are equal to negative 10, so I want my circle to be filled in there, closed circle. It's all my values that are less than or equal to, so to the left. Okay, negative 2m less than negative 4. That means negative 2 times m less than negative 4. So whenever I have a variable next to a coefficient like that, that means multiplication. The inverse of multiplying by negative 2 is to divide by negative 2. So I'm going to divide both sides by negative 2. Because negative 2 divided by negative 2, and you divide something by itself, it equals a 1. So this cancels to 1. I just get a 1m. And then negative 4 divided by negative 2 is positive 2. Negative divided by a negative is positive. Now what I have to remember is since I divided by a negative, I must reverse my sign. So my answers are going to be all my m's that are greater than 2. So my original problem started with a less than. My answer has a greater than in it because I divided my equation by a negative. And remember when we did that up top, to make the equation true, you had to flip the sign. So that's the rule. When you divide by a negative when solving, flip the inequality. So we got negative 2, negative 1, 0, 1, 2, 3. I want all my values for 2, not including it, so leave it open, that are greater than. So all my solutions to that are the values that are bigger than 2, and that's what it looks like on the graph. Okay, this one, remember that a fraction bar means division. This is y divided by negative 5. That's what that means. I could rewrite this as y divided by negative 5 equals 6. So the inverse of dividing by negative 5 is going to be multiply by negative 5. And then whatever we do on the left, we have to do on the right. We're going to multiply by negative 5. Dividing by negative 5 and multiplying by negative 5 cancels that. Typically in algebra, we write it like this. We multiply, we think of this as a fraction, 1 over negative 5. So then we multiply both sides by negative 5 over 1. And that's how you see it in algebra, because then you get negative 5y and negative 5. The negative 5's equal 1. So you're left with just y. And then we're, oh shoot, this was supposed to be an inequality again. So let's make it a greater than in our original. Y is greater than or equal to, greater than or equal to 6. So then 6 times negative 5 will be negative 30. And because I multiplied by a negative 5 in this case, I do have to reverse the sign. So it started as greater than, so we flip it around and it'll be less than. And that's because we multiplied by a negative number. So graphing this, we'll put negative 30 here. Now to the left, it's going to get bigger, like negative 31, negative 32, negative 33. It's getting more negative. And then to the right, you count down, negative 29, negative 28. These ones are bigger, negative 27. I want a closed circle this time at 30 because it's equal to negative 30 there. And then all the values to the left. All right, Make sure to do the 3.2b homework after watching this video.